This video is going to provide a quick review of the Cartesian coordinate system and how to find the distance between 2 points in that system. It's important to understand these ideas because the Cartesian plane lets us describe location using numbers. It's very important as we learn to graph that we understand that system. Distance is going to help us make a connection between geometry and algebra. We'll see that we use the Pythagorean theorem in order to connect these ideas. These ideas are going to pop up all the time throughout algebra, precalculus, and calculus classes. Let's start by discussing some key definitions and formulas that will help us understand the Cartesian plane and the distance formula. So the Cartesian plane is a coordinate plane that contains an x-axis and a y-axis. These are drawn as perpendicular lines. So we typically draw them like this. And it is conventional that the x-axis runs horizontally and the y-axis runs vertically. The point where they meet is typically called the origin. And we label that point with the coordinates 0, 0. So every point in our system is going to be an ordered pair, x and y. The x coordinate tells us the distance we move, and that's signed distance horizontally, or more to the point, along the x-axis, which typically is the horizontal axis. The y-axis then tells us the distance we move, and again, this is signed, and I'll explain what I mean by that in just a second, that we move vertically along the y-axis, which is, conventionally speaking, our vertical axis. You may run across applications where those are switched, and then you just need to understand that the first coordinate tells us which way to move along the x-axis, and the second coordinate tells you which way to move along the y-axis. It's also conventional to list the coordinates in alphabetical order. Now, when I say signed, what I mean is that they can be positive or negative, and that gives you the direction in which you're going to move. The sign gives you the direction. So typically when we have a positive number, we move to the right on the x-axis or up on the y-axis, and a negative number tells us to move the left on the x-axis or down on the y-axis. Then if we have 2 points, let's call them x1, x2. We can just pick some arbitrary points here. We'll call this point x1, y1, and we'll pick some other arbitrary point, maybe over here. We're going to call this point x2, y2. If we want to know how far it is to get from x1, y1 to x2, y2, what we're going to do is we're going to draw the straight line segment that connects them. And the distance is going to be the length of this segment. The way we find that is we'd make a triangle. If we draw this triangle, then the length of this side, since this point right here, this point is now the point x1, y2. So the length of this segment is x2 minus x1, and the length of this segment is y2 minus y1. So then we use the Pythagorean theorem. Remember, the Pythagorean theorem tells us that if we have a right triangle, and we call this A, B, and C, then a squared plus b squared is equal to c squared. So in our triangle, our a value is x2 minus x1. I wrote x squared instead of x2. That's not what I meant. x2 minus x1 squared. And our b value is y2 minus y1 squared. And that has to equal our distance squared. And if we take the square root of both sides, we get our distance formula. So our distance is, I keep writing x squared instead of x2. x2 minus x1, y2 minus y1, and that's going to be equal to our distance. So let's take a look at a few examples to try these ideas out. All right, for our first example, we're going to graph the points A, which is the point 2, -1, and B is the point 6, 4, and then we're going to find the distance between those. So in order to graph those, I'm going to need some coordinate axes, I need a place to start counting. So I'll go ahead and draw in my axes. And I'm going to note that that point is 0, 0. I'm going to let each of these graph marks be 1. So each tick is going to represent 1. You can always change the spacing in your graph if you need to, as long as you make some note of what scale you're using. So now I'm going to graph the point A. We'll use this color blue to do A. It's 2, 1. That means 2, negative 1, which means we go 2 to the right in the x direction and down 1 in the y direction. And we'll label that point A. And then B is going to be 6 in the x direction, so I can count 1, 2, 3, 4, 5, 6, and then I go up 4 in the y direction, and I plot my point B. And now my distance is going to be the length of the segment that I draw. Oh, I did B in blue as well. That was a little bit silly, but I'm going to roll with it. All right, my distance is going to be the length of this segment. But we know that our distance, using the distance formula, is going to be the square root of, let's call this x1, y1, and call this x2, y2. So we're going to do x2 minus x1, that's 6 minus 2, and we'll square that. And then we're going to do 4 minus negative 1. We got to be careful with our signs. So that gives us the square root of 4 squared plus 5 squared, which is the square root of 16 plus 25. When we add those together, 35, 41. And now we might want to try to simplify this, but 41 is a prime number, which means it has no perfect squares that divide it. So there's no simplification that we can do on that. So our final answer is that the distance between those is the square root of 41. Let's do one more just to really firm up our knowledge of this. So we're going to graph the points negative 3, 5 and 4, negative 2. So again, I'll start with some axes, x and y axes. So this is our x-axis, this is our y-axis. And this time I'm going to change my scale just to show how one might go about that. So I'm going to let each of these represent, every 2 is now going to represent 1. So I'm going to mark my scale on here so that somebody who's reading my work knows that now every 2 blocks counts as 1. So now I'm going to plot the point A, which is negative 3, 5. I'll use this color for that. So I'm going negative 3 to the, so negative 3 means go 3 to the left from our origin. So now counting off 3, I have 1, 2, 3. So that's 3 to the left and then 5 up. So that's going to be 1, 2, 3, 4. Whoops, I kind of ran out of space. I'm just going to have to fake it a little bit here and put my point A there. And then B is going to be 4 to the right. So let's use a different color for B. We'll use this blue or purple, whatever you want to call that. We go 1, 2, 3, 4 over. And negative 2, so that means go 2 down, 1, 2. Remembering again that every 2 spaces counts as 1. So those are going to intersect here at 4, negative 2, and that is my point B. And so now I'm trying to find the length of this very long segment here. See if I can make that straight. Yeah, there we go. That's going to be, so our distance is going to be the length of this line that I just drew. So we'll use our distance formula. We're going to say that the distance is the square root. I'm going to do them, it does not matter which point I call first. So I'm going to let this one be x2, y2 this time, and this one be x1, y1. So now I'm going to do, again, x2 minus y2. So I'm going to do negative 3 minus 4 squared plus 5 minus negative 2 squared, and that gives me the square root of negative 3 minus 4 is negative 7 and squared, and then 5 minus negative 2 is positive 7 squared. So I get the square root of 49 plus 49, which is the square root of 98. That one is divisible by a square root, perfect square. It's 49 times 2. So we can split that into the square root of 49 and the square root of 2. The square root of 49 is 7, so our distance is 7 square roots of 2. All right, so we'll finish with a wrap-up of what we've learned. Ordered pairs, x, y, tell us what lengths to move on a set of coordinate axes. So typically we have an x and y axis, and the first coordinate tells us how far to move along the x-axis. And the y-coordinate tells us how far to move along the y-axis. The place where those two meet is going to be our origin or our starting point. And then we know that the distance formula for the points x1, y1 and x2, y2 is going to be equal to the square root of the difference in the x-coordinate squared plus the difference of the y-coordinate squared. And we saw that this formula comes from an application of the Pythagorean theorem from geometry.